And I kind of talk about this question. One of the questions here was, why do we prefer working with the shell? And part of it is it's the same syntax that we code with, and it gets you practice with that. And again, it actually turns out that most of the time it's actually pretty fast.
So would there be any instances where like you might recommend using Compass?
I use it when I'm maybe less familiar with the database.
Okay.
When I'm less familiar with the database, then Compass can be a little bit more friendly. The problem is it's kind of hiding the code that you're writing behind it, right? So it doesn't give you practice with writing the code. That's the downside, which right now that's the most important thing for you, is to get practice with writing the code.
So this is just kind of a follow-up question.
Yeah.
To that. Do you think, like in the industry, we can see more people using Compass than Shell? Just because
I think you're going to see a mix. I think you see a mix. As far as the industry goes, it's really a preference thing, right? Some people prefer to use Compass, some people prefer to use the shell. I have personally found there are some cases, there are some things specifically with indexes especially, that Compass doesn't fully support. So in terms of, there's a specific kind of index that you can create called a full text index. I actually can't create a full text index using Compass. I can only do that using a shell, unfortunately. So there are some gaps there where the shell can do it, but the Compass has sort of historically been a little bit more limited with creating and managing indexes. Okay. On to the next one. So confirming here, what was it? I could say that I could see this becoming a common issue because the idea that most people think indexes are great. What could be wrong is if I just add a bunch of indexes. Problem with thinking. Yeah. So anyway, as far as entry-level developers especially, indexes is a hard thing to understand. It will take you some time. Understanding fully what indexes you need and don't need and all of that will probably take you 2 to 4 years to really become an expert on it, personally. It takes a lot of experience, it takes a lot of practice, it takes a lot of testing your assumptions to get to that point. Okay? It's not something you're going to become an expert over. But it's something you need to constantly have in your mind. What indexes do I need? What indexes do I not need? It's not something you can simply ignore because the performance difference with and without them is so significant. Okay, it's not something you can put off and say I'm going to learn later, but it is something you should constantly asking and working with your team and your lead developer and things like that, asking the questions and analyzing and seeing, are those indexes being used? Are they not being used? But it takes some practice, okay? And it's what you see is going to change as you build the application. The further you get on in the application, the better view you're going to have about what indexes you need and what indexes you don't need. Does that make sense? Like we can make some guesses today. The actual answers may be later. So things to remember, indexes in general are going to make your reads faster and your writes slower. Write that down. Your indexes make your reads faster and your writes slower. That's the key trade-off that you need to understand. Make your reading the data faster, but they make writing the data slower. They come with a certain amount of storage space that they need to kind of have them and keep them. Remember with the wired tiger setup, each index is a file, right? So there's a limit there, but the key trade-off is to understand the difference between reads and writes. That's generally the trade-off that you're making.
That's because the index is essentially a copy of the data set.
Yeah.
Twice.
Yeah, it's a little bit of a copy of the data. So anytime you make a change to the data, you have to update the index as well. So it's more work anytime you need to change the data, but it's less work when you need to read the data because it makes it you avoid what's called the collection scan. The collection scan where you have to look at every single record in the collection, right? And so with an index, you may get it down to you only need to inspect 5 documents in the collection instead of 1,000,000 documents in the collection, which is why you can't ignore them, right? The difference there is so significant. Now here's one specific one that I wanted to, there's a question here about indexing the hobby specifically here. So she's got some indexes. It's a little bit blurry, so it's a little bit hard to see, and I apologize for that. So I'll read off kind of what we see.
Indexes are being
here.
used regularly.
Oh, I lost it now. So she's got an index. You've got an index on the primary key ID. She's also got an index on the first name, the last name, the hobbies, and the full name is what we're seeing here. And birthday's in there too. So birthday, first name, hobbies, last name, and first name. So the two things that she's highlighting is the thing about the hobbies and the thing about the last name and the first name. So this last name, first name index, anytime you have an index that refers to multiple columns, oftentimes that index can be used for a single column by itself. Okay, so this last name, first name index can actually be used entirely in place of the last name index. Basically, this index says it's sorted by last name and then by first name.
Is that something with the hobbies?
Hobbies is a different story, right? So just talking about the names for a second. So having last name, first name index means I don't need to index last name by itself. This index is entirely redundant. A gotcha, though, is the first name index is not redundant. The first name index is not redundant because this is last name, first name. So while it can use it just for last name, it can't use this just for first name. It's not sorted that way. So oftentimes what I do with user databases like this, I'll actually create 2 indexes, one that is last name, first name, and the other one that's first name, last name. And that covers any scenarios where you want to sort by last name or sort by first name. So you generally end up finding those 2 indexes. Does that make sense? That's one of the gotchas. The order that you define the columns in actually does matter. Okay, so that's why in this case the last name index is redundant, but the first name index is not. Okay, hobbies is a little bit of a different story. So here in there, she's saying the hobbies wasn't used. Well, it is being used. It is being used, so we need it. Hobbies is not covered by anything else. It's worth noting that hobbies is an array because these people can have, these inspirational women, as it is, can have multiple hobbies. So we're actually indexing an array, which is kind of interesting. It's kind of actually it's a really advanced sort of index here. This is actually one of those things that makes a huge difference because it provides me a way to quickly find people that have a certain hobby. It's actually much more efficient than you can do in SQL. Because the problem with SQL is you have to push the hobbies over to another table and then do a join to kind of bring it back together. It turns out there's no efficient way to do the indexing in SQL because of that. Because of the need to break things up, there is no efficient way to do a query like that. For somebody that has, like, say, hey, we have fishing as a hobby. Because you end up with, basically the way it ends up is you say, okay, well, I can index the hobbies table, or the user hobbies table, and I can index the users table, but the users table doesn't actually have the name of the hobby, so I can't index it based on that. And well, actually I take that back. I can't even put the hobby information into the users table, so I can't do that. I have to go like, okay, I'll go over to the users hobbies table, look through that, and see, okay, well, fishing is number 6. All right, so let's find all those. And I have to go back, and now, people can have multiple copies. I might end up with multiple rows per user, and then I have to start grouping it together, and it becomes a whole complicated mess, is the long and short. Like having these things where you have an array, here it's array of hobbies, the course says it was array of days that the course meets. All of those turn out to be really inefficient in SQL. You tracking with me there? Like this ability to have a nested array and do n is really, really, really efficient. And so the fact that we can index those arrays, right, is really helpful. Okay. Now, generally, when we're doing things like indexing a name, for each record, each document, we're only getting one entry into the index, right? So we think, okay, if I've got 1,000 people, then there's 1,000 nodes in the index. But when I'm indexing this array, so let's say, okay, everybody's got 3 hobbies. Every person has 3 hobbies, and we got 300 have 1,000 people. There's actually 3,000 nodes in that index. So actually 3,000 nodes in that index because of how it has to operate. Does that make sense? Sort of. It's actually really cool. So that's one thing I wanted to call to your attention real quick. Like that is something we absolutely want to index, is arrays like that, and it makes a huge difference.